Welcome back, students. We'll be looking at section 2.7, terminology for solving linear inequalities. So remember, for inequalities, we read inequalities from left to right. And we had this chart right here in a previous section when we first started learning about inequalities. I'm not going to go through this again. I just wanted to have it on the page for you so you had it as a frame of reference to review as you're going through this section. All right, so let's talk about our new terminology. We have what's called a set builder notation. So the way we would read this is the set of all x, basically any value of x, excuse me, such that x is less than or equal to 8. So they're basically saying this solution set includes all values of x that are less than or equal to 8. Now let's talk about infinity symbols. We have two symbols for infinities. We have negative infinity and positive infinity. And they look like a 8 that's fell on its side, basically. Plug in negative infinity here. Numbers approach negative infinity as they move left on the number line. So negative infinity has to do with moving left. Numbers that are less than, basically. So less than or equal to. That's what it has to deal with. Numbers approach positive infinity as they move right on the number line. So they go to the right. They're increasing in value, basically. So those are the greater than or the greater than or equal to. A parentheses, change colors here. Let's go with yellow. A parentheses indicates that an endpoint is not included. Okay. Those are when you have less than or greater than. A bracket indicates that an endpoint is included. So those are the less than or equal to or the greater than or equal to. A parentheses is always used next to an infinity symbol. Because there's no endpoint. There's no endpoint to include, so you can't have a bracket. All right, the set of all real numbers is written in interval notation as parentheses, negative infinity, comma, positive infinity, parentheses. And what they mean by the set of all real numbers is basically all numbers are included in the solution set. It doesn't matter what the number is, it's included. So if all real numbers are the solution set, then this is how you would write it, negative infinity to positive infinity. Now let's look how we would graph these inequalities on a number line and also how we would write their specific interval notation for each of these problems. When you're graphing an interval, the part that you need to pay attention to is this part right here, what that part says, because that's going to tell you how to label the number line. So x is less than 4. So the number that I'm referencing is 4, but the value of x, any solution to x, must be a number that's less than 4. So that tells me my arrow is going to go in the less than direction. Now it tells I need to look and see, is 4 included or not? It doesn't say or equal to, so 4 is not included. So that means I'm going to have a parentheses at this end of my line that I graphed with. Now let's look at the interval notation. It's going towards negative infinity. So I'm going to have parentheses, negative infinity first, comma, 4 is my reference point, my number reference point, and 4 is not included. So I'm going to have a parentheses here. Let's look at the next one. Now we have x is greater than 4. So 4 is still our reference point, but the values of x are greater than. So I'm going to go in this direction here. Again, 4 is not included because it doesn't have the or equal to, so I'm going to have a parentheses at the end. My interval notation is going to have parentheses 4, comma, positive infinity. And remember, your negative infinity is always on the left, positive infinity is always on the right. Think it's going to be on the side that the direction of your arrow is going towards, left or right, okay? Now let's look at this next one. I'm going to change colors here. X is less than or equal to 4. So 4 is still our reference point. They're telling us that X is less than or equal to. So it's going to go this direction. But 4 is included this time because it says or equal to. So instead of a parentheses, I'm going to have the bracket because the bracket indicates that 4 is also part of the solution set. The way we'll write this is parentheses, negative infinity. Remember, parentheses is always with the infinities, comma, 4, bracket. Next one has X is greater than or equal to 4. So we're going to start at 4 again. This time our values for X is going to go to the right because they're greater than. 4 is included because it has the or equal to. So I'm going to have my bracket. We're going to have bracket 4, comma, positive infinity, parentheses. Our next one has all real numbers. So, yeah, our little bracket, I forgot that on the page. So all real numbers, that means any number you can think of or can't think of is included in our solution set. So remember, the way we write those is parentheses, negative infinity, comma, positive infinity, parentheses. So this whole number line is labeled infinitely in both directions. There is no stopping point. The next one. The next one has 2 numbers on either side of X. We also have 2 inequalities. So what it's telling us is that the values of X are in between those 2 numbers. They are our endpoints, basically. There are limits to where our solutions are. So we're not going to have any negative or positive infinities in the next few. We're going to have actual numbers in our interval notation. So negative 2 is less than X. All right, so I'm going to circle my negative 2. And then X is less than 4. 4 is our other reference here. Is negative 2 included in our solution set? No, it doesn't say less than or equal to. So that means I have a parentheses above it. What about the 4? No, it's a less than, not a less than or equal to. So it also has a parentheses. We're going to connect these two. And what this tells us is that our value of X is in between these 2 parentheses. Doesn't include negative 2 and 4. It's every number in between them that is a part of the solution set. Our interval notation is going to have parentheses, negative 2, comma, 4, parentheses. Next one has negative 2 is less than X. So again, negative 2 is not included. So I'm going to have a parentheses here. X is less than or equal to 4. Now 4 is included, so I'm going to have a bracket above it. Connect them, and X is the value in between those 2. The way we would write our interval notation is a parentheses, negative 2, because it's not included, comma, 4, bracket. 4 is included, so we have a bracket. Next one has negative 2, less than or equal to X. So negative 2 now is included, so I'm going to have a bracket. X is less than 4. 4 is no longer included. So I'm going to have a parentheses and connect them. So X is in between here, any number in between those 2 numbers, including negative 2. So let's write our interval notation. We have a bracket, negative 2, comma, 4, parentheses. 4 is not included. The last one has negative 2 is less than or equal to X, which is less than or equal to 4. Both of them are now included in the solution set. So I'm going to circle both of them. I'm going to put brackets above and connect them. And X is the value of x is in between these brackets, including -2 and 4. So the way we'll write our interval notation is bracket -2, comma, 4, bracket. Now let's look at the addition property of inequality. So we're going to solve some inequalities using the addition property, and then we're going to map them on the number line and write the interval notation that goes along with the solution. So the first thing we're going to do is add 1 to both sides on this first example. I end up with 0 plus 8x is less than 7x plus 3. Rewrite that. I'm going to subtract 7x from both sides. I get 1x is less than 0 plus 3. So my solution is x is less than 3. This is what I'm going to be mapping on this number line. I locate the 3, and then I look and see what the inequality tells me. The values of x are less than 3. It doesn't include 3. It's all the numbers less than 3. So I'm going to be going this direction, and because it doesn't include 3, I have a parentheses at the end here. Now my interval notation is going to be -infinity, comma, 3 parentheses. Now let's look at the next one. 5 plus 5x is greater than or equal to 4x plus 3. Subtract 5 from both sides. I have 0 plus 5x is greater than or equal to 4x minus 2. I'm going to rewrite it. I'm now going to subtract 4x from both sides. I get 1x is greater than or equal to 0 minus 2. Rewrite that over here. We have x is greater than or equal to -2. This is our solution set. So I need to find -2. Here it is, right here. And what the inequality tells me is the value of x is greater than or equal to -2. So all the values greater than -2 and equal to -2. So I'm going to have a bracket. Our interval notation is going to be a bracket, -2, comma, positive infinity. Now let's look at the multiplication property of inequality. It has a new rule, basically. So we're still going to use the old rules of when you divide and multiply to get a variable by itself. But it's basically an additional rule when you're dealing with inequalities. So if you multiply or divide by a negative number, then you flip the inequality symbol. We're going to go through 2 examples here. One where we do flip the inequality, one where we don't, just so you can see the difference between the two. So in this first example, we have a positive 3x is less than -18. It's the 3 that tells me whether or not I'm going to flip. It's the number that you're moving that tells you that. This 3 is a positive, and I'm going to divide by a positive 3 on both sides. Since I'm dividing by a positive number, I'm not going to flip, okay? So we end up with x is less than -6. Let's go ahead and graph that. So -6 is right here. Our values of x must be less than that, not including -6, but less than. So it's a parentheses, and then our arrow going towards the left. Our interval notation is going to be -infinity, comma, -6, parentheses. Now let's look at an example where we will flip the inequality. So in the first example, we divided by a positive 3, so we didn't flip it. In this second example, we're going to divide by a -4 on both sides. So because we're dividing by a negative number, we're going to flip the inequality. So our answer will be x is less than or equal to -2 because we flipped that inequality. So our frame of reference is the -2. And it tells us that x is less than or equal to that. So it includes a -2. So I'm going to have my bracket, and x is less than that. So I'm going to go to the left. So my interval notation is going to be a -infinity, comma, -2 bracket, since -2 is included. Steps for solving linear inequalities with one variable. The main goal is to get the variable all by itself, just like when you're dealing with an equal sign. So that doesn't change. You want to get the variable on one side, the number on the other side, what it's equal to or less than or greater than on the other side. Step 1, simplify each side of the inequality separately. Very important to do this before moving on to step 2. So that includes distributing property, simplifying any areas with parentheses, using multiplication to change fractions or decimals into whole numbers, and combining like terms. You want to do all of that before you start shifting from side to side. The next thing is to use the addition property of inequality. That's where you are adding or subtracting items from side to side. Step 3 is to use the multiplication property of inequality, which we just did, to isolate a variable. And the key part is remember to flip the inequality symbol if you multiply or divide by a negative number. Step 4, check your work by substituting the value found into the original inequality. So you can pick any number within your solution set, plug it into the original problem, and see if it's true. If it's not true, then you've done something wrong, okay? So let's look at solving a linear inequality. And remember, linear means line, a straight line. So let's look at number 1. We have a -15 minus 2w plus 1 is greater than or equal to 4 times w minus 1 minus 3w. The first thing I need to do is I need to distribute this invisible -1 to the items in this parentheses. And I need to distribute the 4 to the items in that parentheses. So I have -15 minus 2w minus 1 is greater than or equal to 4w minus 4 minus 3w. Now I need to combine like terms if possible. On the left-hand side, I can combine the -15 and the -1 and get -16. And then I still have the minus 2w. Greater than or equal to. On the right-hand side, I can combine the 4w minus the 3w and get 1w, or just w. And I have the minus 4 still there. Now that I've fully combined and simplified down as much as possible, I can start moving things from side to side. I'm going to add 16 to both sides. I have 0 minus 2w is greater than or equal to w plus 12. Rewrite that. -2w is greater than or equal to w plus 12. I'm going to subtract w from both sides. I get a -3w greater than or equal to 0 plus 12. That's -3w is greater than or equal to 12. I'm going to bring this up here so we can finish it. We're going to divide both sides by a -3. Don't forget, because we're dividing by a -3, we're actually going to flip our sign. So w is now less than or equal to -4. This is what we will graph. So I'm going to find -4. Here it is. It says w is less than or equal to that. So -4 is included in our solution and any number less than. So we're going to go this direction. The interval notation would be -infinity all the way to -4, and -4 is included, so we have our bracket. Number 2, we have 3/4 times k minus 6 is less than 2/3 times 5k plus 1. The first thing I want to do is get rid of these fractions. I don't want to have to distribute them if I don't have to. So I'm going to multiply them by a number that will cancel out the 4 and the 3 eventually. A multiplication fact that they share is 12. So that's what I'm going to use. I'm going to use 12 over 1. So I'm going to say 12 over 1 times the 3/4 k minus 6, and then 12 over 1 times 2/3 5k plus 1. 12 times 3 is 36 over 4. And then 12 times 2 is 24 over 3. That 36 over 4 reduces to 9. And then 24 over 3 reduces to 8. So now we can distribute. We end up with 9k minus 54 is less than 40k plus 8. I'm going to add 54 to both sides. I end up with 9k plus 0 is less than 40k plus 62. All right, I'm going to bring it up over here so we can finish it. I end up with 9k is less than 40k plus 62. I need to subtract the 40k from both sides. I end up with negative 31k is less than 0 plus 62. Now notice I didn't flip my inequality symbol just because I was subtracting a number. You only flip it if you multiply or divide by a negative number. Okay, so don't forget that. So this is a negative 31k less than 62. I'm going to divide both sides by a negative 31. And since I divided by a negative number, I am going to flip the inequality symbol this time, and because I get k is greater than negative 2. This is what I'm going to plot on my graph. So negative 2 is here. K is greater than that. Does not include it, but it is greater, so I have a parentheses. My interval notation would be parentheses negative 2, comma, positive infinity. Now let's look at using applied problem, or excuse me, look at applied problems using inequalities. So again, if it says is less than, so think translating, less than, it's going to be x is less than 5. You're going to write it like this. So if it says a number is less than 5, or a number is greater than 5, a number exceeds 5, a number is at most 5, a number is at least 5. These are the patterns of what you would translate it into from a word problem. All right, let's look at something that I don't want you to get confused though. Do not confuse when translating. 5 is more than a number. This is how you translate it. That key word is, okay? If it says 5 more than a number, there's no is in there, then it's 5 plus that number. So the difference is the word is. That's how you know whether or not you're going to use an inequality in these type of problems, or just saying 5 plus something, okay? So let's look back up here because I want to point that out. I had a number is less than 5, and then we wrote it as x less than 5. A number is greater than 5, so that's our x is greater than 5. A number exceeds 5, that means greater than. It's larger than 5. It goes past it. That's why I have x greater than 5. The next one has a number is at most 5. Is. So x is less than or equal to 5. Can't go over 5. So that's where it says at most. That means 5 is the highest number it can be. So when you write your answer, you're going to write x must be less than or equal to 5. It can't be more than that. The opposite of that is a number is at least 5. So it must be 5 or greater. The lowest it can be is 5 at least. So we're going to have x is greater than or equal to 5. So hopefully now you can see how having that word is in there changes what you're going to write as your answer. If the word is not there, then you're translating like you were previously. All right, finding an average test score. Brent has scores of 86, 88, and 78 out of a possible 100 on each of his first 3 tests in geometry. If he wants an average of at least 80 after his 4th test, what are the possible scores he can make on that test? All right, so if it says at least, that's this version right here. So we're going to have something where our inequality is this with 80 over here. Whatever's on this left-hand side must be greater than or equal to 80 based on what they're asking us. All right, so let's figure out how to fill in the left-hand side. Brent has scores of 86, 88, and 78 on his first 3 tests. We don't know his 4th test. They want to know what he has to make to get an average. That means we're going to divide. Remember, average means division. So what we're going to divide is his total math score from all his tests, okay? So I have 86 plus 88 plus 78 plus that mystery test score that he hasn't done yet, because we're trying to figure out what he has to make on that test to keep at least an 80 in the class. We're going to divide, to get the average, we need to divide by the number of tests that we have, which is 4. Now let's work towards solving the problem. I'm going to multiply both sides by 4 because I want to get rid of that 4 in the denominator. So I'm going to rewrite that. 4 times 86 plus 88 plus 78 plus x over the 4. If I do that on that side, I need to do it on the other side. Okay, so remember, if I multiply on one side like that, I need to multiply on the other side. This 4 cancels that 4 out. So I end up with 86 plus 88 plus 78 plus x is greater than or equal to 80 times 4 is 320. Now I need to combine like terms, which is the 86, the 88, and the 78. When I combine those, I get 252 plus x is greater than or equal to 320. I'm going to bring that up over here so we can have enough room to finish it. I'm going to subtract 252 from both sides to get the x by itself. So 0 plus x is greater than or equal to 68. Got my x in there. All right, so x is greater than or equal to 68. All right, so for Brent to keep at least an 80, a minimum of an 80 in his class, he must make at least a 68 or higher on his test. If he makes below a 68, he will not end the class with an 80. Okay, so that's what this is telling us here. All right, looking at our next grouping here. Solving linear inequalities with 3 parts. And this is our last section, but it's important because it's a little bit different. It's probably something that you either haven't seen at all or you only saw for a short period in school. So it might seem somewhat brand new to you. So on this first one, we have -5 is less than x, which is less than -1. We don't have to solve this one. X is already by itself. So we're just going to map this one. -5, I'm going to circle it. And -1, I'm going to circle it. Now, the inequality that is attached to the -5 is a less than. It's not less than or equal to. So the -5 is not included. So I'm going to have a parentheses. The -1, its inequality is also not an or equal to. So -1 is not included. So it has a parentheses. And x is in between those numbers. So our value of x is in between those numbers. So the way we would write this one is going to be parentheses, -5, comma, -1, parentheses. Looking at our next one, it's the same deal. We've got the x is already by itself in the middle. It doesn't have anything else with it. So we can actually go ahead and map this one out. We have -2 and 4 as our endpoints. The inequality connected to the -2 is less than, not less than or equal to, it's just less than. So it's a parentheses. The one connected to the 4 is a less than or equal to. So it does include 4. So I'm gonna have a bracket and then we're gonna connect them. So x, the value of x has to be greater than -2 or less than or equal to 4, somewhere in there, okay? Now let's look at these next two examples. These are the ones that I was talking about where it might seem brand new to you. But what we're gonna do is the same steps to get x by itself. We're just gonna be solving it with both ends of this problem. So I noticed the 3x minus 1 in the middle. I need to get the x by itself. So the first thing I'm gonna do is move that -1. To move it, I need to do the opposite. So I'm going to add 1. But when I add 1 there, I'm also gonna add 1 to both ends of this inequality. Just like this. So I have 2 plus 1, which is 3, less than or equal to 3x plus 0, which is less than or equal to 9. I'm going to rewrite that. All right, so now what we have in the middle with the x is a 3 being multiplied against it. We need to divide by 3 to move that 3. If I divide this by 3, then I need to divide both ends by 3 as well. So divide by 3, divide by 3. So what I end up with is 1 is less than or equal to x, which is less than or equal to 3. So this comes up here. This is what we will actually graph, because the 3 over 3 becomes a 1. The 9 over 3 becomes a 3 when we reduce those fractions. I'm going to find the 1 on my number line and the 3. We have the less than or equal to inequalities attached to both of those. So that means they are part of the solution. So both of them end up with a bracket. And then I connect them. So that's our graphing. The interval notation will be a bracket, 1, comma, 3, bracket. Let's do a second example. 4 is less than 3x minus 5, less than or equal to 10. So the first thing I'm going to do is add 5 to both ends and the middle. I get 9 is less than 3x plus 0, which is less than or equal to 15. I'm going to rewrite this. We have 3x by itself in the middle now. I'm going to divide by 3 on both ends and in the middle to get rid of that 3. So I end up with 3 less than x less than or equal to 5 when I simplify. Find the 3 and the 5. The inequality attached to the 3 is just a less than, so it's going to be a parentheses. The 5 has a less than or equal to, so it's a bracket, and then I connect them. So our value of x is in between there and including 5. Our interval notation would be a parentheses, 3, comma, 5, bracket, because the 5 is included. All right, let's look at our Bible verse. Very truly I tell you, no servant is greater than his master, nor is a messenger greater than the one who sent him. John 13:16. All right, guys, I hope you're having a great day, and I'll see you in the next video. Bye.